Okay, so we are now in the topic ellipse. Okay, so from the previous topic, in the species of the conic, we have already know that an ellipse is identified when e or eccentricity is less than 1. Okay, so an ellipse is the path generated by a moving point so that the sum of its distance from the foci is always equal to the length of the major axis. So if we will convert that into an equation, so we have this ellipse here. Okay, so say this is the moving point that is being mentioned here. Okay, so moving point is distance from the foci. So if this is the foci 1, so that is f1. So this is f2. Okay, so if this distance is denoted as df, okay, and this distance from the moving point to the second foci is df2. So the sum, so meaning, so that is df1 plus df2. Okay, so that the sum of its distance from the foci is always equal. Okay, so that is always equal to the length of the major axis to A. Okay, so uh, what this definition meant. Okay, so this is the equation for ellipse. Okay, so for you to get this equation here, then you can derive it. Okay, so using this equation here. Okay, so you may use distance formula again. So since you have this point for your foci 1, you also has the point for P, then for F2 or the foci 2. So I will not derive it already, guys, since it's very tedious, okay, to derive this equation. Okay, so anyway, so this will be our standard equation for this ellipse that we have in here. Okay, so we will discuss the elements of an ellipse. So say you have this ellipse here, then uh, the the center is at the origin. Okay, so 0 or O. Then you have this we have 4 vertices for an ellipse. So you have this V1 here, V2, V3, and V4. Okay, then the same with parabola, you have this foci. Okay, you have 2 focus. Okay, and also you have 2 directrices. Okay, the left and the right. Okay, so this is the standard equation for an ellipse. So x squared over a squared plus y squared over b squared is equal to 1. So now, so standard equation for an ellipse. So this equation here is center is at 0, center at 0, 0. Okay, then this 2 here has a center at hk. Okay, so this is the first ellipse. Okay, so the center is at 0, 0. So the equation for that ellipse is x squared over a squared plus y squared over b squared is equal to 1. Okay, so for second ellipse, elongated with respect to y. So the equation of this second ellipse is x squared over b squared plus y squared over a squared is equal to 1. Okay, then for number 3, so the center is not at the origin, so center is at hk. So this is number 3, also the same with this ellipse here. So the center is at hk. Okay, so for the equation of this ellipse is x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Okay, so elongated with respect to x. Then for the ellipse, this ellipse here, okay, so elongated with respect to y. So again, the center is at hk. And the same with this, the center at hk. So the equation for this ellipse elongated with respect to y is equal to x minus h squared over b squared plus y minus k squared over a squared is equal to 1. Okay, so those are the standard equation for the ellipse. The next, okay, so say we have this ellipse here. Okay, so we have that ellipse here. Okay, so we have this x and y equations here. Okay, so this is your v1. Okay, then this is your v2. Okay, so from v1 to v2, so the distance in that is equal to 2a, or that is a. Okay, so a from here, then a from this. Okay, so that's why that is equal to 2a, distance between the two vertices when it comes to this orientation. The next, for say this is your v3 and this is your v4. Okay, so the distance between 4 to the origin, so this is b, same with this, so this, from the v3 to the origin is b. Okay, so that's why the distance from v3 to v4 is equal to 2b. So that will be your minor axis. Okay, so major axis is the longer length. Okay, so the minor axis is the shorter length. Okay, then we have this two focus. So say this is your f1, that is your focus, then this is your f2. Okay, so the distance between f1 to f2 is 2c, or that is c. Okay, c is from f1 to the origin, then from the origin to f2, so that is your c. Okay, so that is the distance between the foci. Then distance between directrices, so you have a directrix here. Okay, so you have this directrix here, and also the opposite side, so directrix. Okay, so distance between the directrices is 2d. So again, from the center to the directrix, that is d distance. Then from the center to the left directrix is d distance as well. Okay, so that's why that is equal to 2d. So next, from the general equation of a conic, so again we have this equation here. So this represents an ellipse if a times c is greater than 0. Okay, so in here, a is always greater than b and c. Okay, so since a is the major axis, so a can be we can get a by equating it to square root of c or square root of a, whichever is greater. Okay, so the same with circle, guys. We have this formula so that we could directly get the center, okay, the center of our ellipse. So if given the general equation, so we have this h is equal to negative d over 2a, so that is for the x coordinate of our center. Then k is equal to negative e over 2c. Okay, so if we will be using this formula, then also we could get as well directly the value of our eccentricity, which is equal to c over a. Also the distance from the center to the directrix, d, is equal to a over e, or a squared over c. Then we also have a squared is equal to b squared plus c squared. So this is the relationship between the three distances that we have discussed earlier. Okay, so this is Pythagorean theorem because as we can see in here, okay, So we have from the origin to the foci, so we have this C here. Okay, so from the origin to the vertex or V3, so we have B. Then the distance from the vertex to the foci is equal to A. Okay, so that is a right triangle. So you see Pythagorean Theorem. So we have A squared is equal to B squared plus C squared. Okay, so that's why we get this equation. And lastly, for the latus rectum, the length of the latus rectum is equal to 2B squared over A. So again, we have this latus rectum here. So this is the focus. Then we have this latus rectum. Okay, so again, we have two latus rectum. So say this is L, then this is R. Then also we have latus rectum here that passes through the focus. L, then R. So sometimes we are also required to get the coordinates of our latus rectum. Okay, or the point of this latus rectum. Then we have these properties of ellipse. Okay, so in order to get the area of an ellipse, so we have this formula here. Area is equal to pi AB. Then how about if we are required to get the perimeter? So we have two formula. So P is equal to 2 pi square root of A squared plus B squared over 2. Then we also have 2 pi square root of A squared plus AB plus B squared over 3. So this is more accurate than the first formula. Okay, but the two equations will do, but preferably you will be using this second equation at B. Then we have this angle of incidence is equal to angle of deflection. Okay, so that's all for the introduction for ellipse. So our part 2 will be solving problems about ellipse.